So it's not hard, it just takes some explaining, and I need you to kind of discover it. So I'm going along and doing it a little bit slowly so that you can discover what's happening. Okay, so where the stolen triangle comes from. Pascal is the one that we named this triangle after, but it turns out, I don't remember when I don't remember, but when he discovered it, was 250 years after 2 other people already discovered it. Somebody who was Chinese and somebody who was Persian. And yet we call it by the name of the white guy. So that's why I'm saying that a stolen triangle. So rows. This is called row 0. The first one is row 0. I'll tell you why that is in a bit. This would be row 1. This would be row 2. This would be row 3. So they're going up by 1, right?
4. 5.
So go ahead and fill that in what those rows are.
7. 8. 30.
So how might you know what the row is according to the numbers in that row? Notice anything that corresponds with that row number and the triangle in that row. So these numbers here correspond with the row number. So what we do is this is a way to show a binomial expansion. What is a binomial? 2 terms. So when we're expanding it, we're multiplying it, taking it to some exponent. So before we do that, I want to talk about what is 4 to the 0.
0. No. Is it 4?
It's 0. It's 1. It's 1. It's 1. 21. It's 1.
What is 4 to the 0? I need you to think because we're going to do this a lot today. What is 4 to the 0?
1.
1. 4 to the 0 is 1. Let me show you why. What's 4 to the 3rd? Feel free to get a calculator, and you really want to be able to use your exponent keys on the calculator. So ask your group members or ask me if you need some help on that. What is 4 to the 3rd? 64. What is 4 squared? 16. What is 4 to the 1? 4. So what is my pattern here as I go down? As I go down this direction, T smaller, can we be more specific than that? Divided by 4. Good, Emma. So we're dividing by 4. 64 divided by 4 is 16. 16 divided by 4 is 4. What's 4 divided by 4? 1. So that's where that comes from. So what do you think 2 to the 0 would be? 1. Okay, so you've learned that in Algebra 1, but it's constant a lot, and we need a lot of reminders of that. I always need to remind a lot of people of that in Algebra 2. Okay, so what we can do is we can expand a binomial using this. So let me pass out the next page of the note. So x plus 2 to the 4th. Remember on the homework assignment you had that? Wasn't it a pain to find that? You take x plus 2 times x plus 2 4 times. It was a pain to do it. So I'm showing you another way today. So first it's going to seem like it's harder than the end here. And this is what I'll require you to use on a test or quiz. Okay, so once again, binomial expansion. Binomial means how many terms? 2. So we are taking x plus 1 squared. Anybody know what x plus 1 squared equals? X squared plus
1. No. 2. 3. Eventually. For
X squared plus 2x plus 1. So I'm just going to tell you what that is. What is the exponent on the x assumed to be? A 1. What's the exponent on the x squared? Or excuse me, the coefficient on the x squared assumed to be? 1. So we're going to look at those coefficients. Okay, so we are going to use, look at those coefficients. 1, 2, 1. Do you see anything in Pascal's triangle that has those coefficients?
Yo. Weird.
Good. I hear a couple people that say row 2. So it's right here, which is row 2. Remember, this is row 0 up here. Once again, thank you those of you that are sitting quietly. So, x plus 1 to the third. What we can do is we can use, actually I'm just going to go ahead and tell you what that is. X to the third plus 3x squared plus 3x cubed, 3x plus 1. So my coefficients, where do they come from? Looking at Pascal's triangle, where do they come from? The coefficients are the numbers in the front. What's assumed to be in front of the x squared? 1. So it's 1, 3, 3, 1. Where in Pascal's triangle can we see that? Row 3. So that exponent is determining that for us. So now let's take a look at a pattern of what's happening with the exponents. Do we see any pattern yet?
Oh, yeah.
On the x's. Do you see that pattern? What's happening with the exponents? Here.
It's getting smaller.
They're getting smaller by?
No. Yeah.
3, 2, 1. And then if I wanted to, I could put x to the 0 here. So 3, 2, 1, 0. This one is 2, 1, 0. So, but the number is 1, 2, 1. So see if you can use that pattern to find out what the next one is. And I'll tell you. Try it, and then I'll tell you.
So,
shove it in. Sorry, could you just shove it in? Sorry, you can just like use it.
You already wrote that out. Fantastic.
Something like 8. Oh, copying the book. Oh, because it's the row.
So where did the coefficients come from? So where do these numbers come from? The coefficients, where do they come from?
The chart.
Row 4, the chart. So this, where does the 4 come from in this? How do we know it's row 4?
Because there's 4.
This is an exponent of 4. Okay, so that's where that comes from. So we have 1, 4, 6, 4, 1 here. Now what about the x's again? What's happening with the x's, the exponents?
Go up on.
They're decreasing by 1. So they started with the 4, then 3, 2, 1, and then no exponent on that one, just an exponent of 0.
it's row 4.
So what is x plus 1 to the 0? Anybody else know what x plus 1 to the 0 would be? It's 1, that's right. And so that's where that row 0 comes from. If we take a binomial, put it to an exponent of 0, we get a 1. Okay? So, what's different on the very last one? And it's already confusing.
No, no.
Does it follow the same pattern on the last one? It doesn't, does it? So what's the reason? What might be the reason in terms of what it looks like? Why is it that it's not following that pattern?
Because it keeps getting bigger.
That's right. We have the x plus 2 this time. So that's what I'm going to show you how to do. Because most of the time you're not going to be given one that has a plus 1 there. So I'm going to show you what to do if this number is something different than 1. Okay, ready? Okay with that? Can I move on to the next slide?
Yes.
Okay, this is the back now. Okay, so we are going to find x plus 2 to the 4th. So we look at which row is on the triangle.
Wait, what's featured? That
The numbers are 1, 4, 6, 4, 1. So we're going to take a 1 times, this is an x, so we're going to take x to, this is a 4, so we're going to take x to the 4th. So now what we do with the 2, it would be 2 to the 0.
1.
What's 2 to the 0?
1.
This one would be 4 times x to what exponent? X to the 3rd, and then times 2 to what exponent?
0.
1. So the exponents on the x's go what direction? The exponent on the x's go what direction? They get smaller by 1. And that's the consecutive by 1. And the 2's, the exponents go higher, start at 0 and increase by 1 each time. So my next one is 6 times x to what exponent? 2 times 2 to the 2. My last one.
Yo, you good?
My next one would be 4 times x to what exponent? 1 times 2 to the 3. And then my last one, 1 times x to the 0 times 2 to the 4th. Okay, we're going to simplify it in the next row, but I need you to ask if, let me know if you have a question at this time. Okay, hopefully you're seeing that pattern. Again, I need you to sit quietly here. Any questions? Okay, so now we're going to simplify it. What is 2 to the 0? 1. 1 times 1 is?
1.
1. So 1 times 1 would be 1x to the 4th or x to the 4th. Sorry, I know I'm talking a lot today. So 2 to the 1 is 2. So we take 2 times 4, which is
8.
8 x to the 3rd. What's 2 squared? 4. So we take 6 times 4, which is 24 x squared. 2 to the 3rd is what?
8.
8. 4 times 8? 32x. And then 2 to the 4th is? 16. 1 times 16 would be 16, and then x to the 0 is just 1. So it's just 16. Questions on that? Okay, so if I take the exponents, 4 plus 0, I get 4. 3 plus 1, I get 4. Sorry, again. 2 plus 2 is 4, 1 plus 3, 4, and 0 plus 4, 4. So always. So now we're going to do the next one. What are the numbers from Pascal's triangle?
That's wrong. Look, you see this shit?
I'm looking.
Right. Look, this shit gotta be a 15. No, because this shit gotta be a 15.
No.
Look at it, bro. No, because look.
Okay, so x plus 2 to the 5th, we're going to take a 1 times x to what exponent? 5 times 2 to what exponent? 0. Remember these numbers, add 2, the 5 and the 0, add to 5. Okay, so this one, 5 times x to the 4 times 2 to the 1. Next one, 10 times x to the 3 times 2 to the 2. Questions on that? Where we're finding that? David, did you have a question on that? Okay. So then the next one, you get the 10, and then, what would the exponent on the x be? 2, and then what about the exponent on the 2? So remember these go up. So 0, 1, 2. What comes after 2? 3. That's right. Or you can think of them as going down if you go right to left. So this one would be 5 times x to the 1 times 2 to the 4th. And last one, tell me how to find that. Omar, how do I find the last one? 1 times?
1 time.
What's happening with the exponent on the x's?
2. No.
This is a 5, this is a 4, this is a 3, this is a 2, this is a 1. What would the next one be?
2, 5,
0.
5, 4, 3, 2, 1. Do you see a pattern? 0, that's right. And so what would the exponent on the 2 be? Hello?
Yeah.
What's the exponent on the 2?
1. Nah. I don't know. 0.
5.
Actually, I don't know.
Let's look at the pattern on the exponents on the 2.
Oh, 5.
5, that's right. Okay, so now we're going to simplify. 2 to the 0 is? 2 to the 0?
2. Oh, 1.
1. 1 times 1 would be 1, x to the 5th. 2 to the 1 is 2. 5 times 2 gives me 10, x to the 4th. What's 2 squared?
40. No, hold on. That's it for 48.
2 to the exponent 2 is 4. So 10 times 4 would be 40, x to the 3rd. What's 2 to the 3rd? 8. So feel free to get up and get a calculator. So we have 10 times 8, which is 80, x squared. What's 2 to the 4th?
8.
2 to the 4th is 2 times 2 times 2 times 2. 2 times 6 times 4.
16. 16.
16. 5 times 16? 80. X. So calculator's nice. But calculator on these is really good. And then 2 to the 5th is 32. So my last number is going to be 32. Questions on that before I do my last example? I know a lot of talking, but I have to get you to discover it. Okay, you guys still looking at this? Thank you, those of you who got it quicker. You're being patient. So what do I start out with?
Row 6.
Go forward. Go forward.
That's my row. Exponent.
1, 4, 6.
1, 4, 6, 4, 1. Questions on how I got the 1, 4, 6, 4, 1? Okay, so I'm going to use that as my coefficient. What's my exponent on the x? Emma. 4. And then what's the exponent on the 3? 0. Questions on how she got that? So next term is 4 times x to the, really, can you tell us the exponent on the x? Good. And then the exponent on the 3?
1.
Yes. And then 6 times, hello, what goes there?
X squared.
Times?
3 squared.
Yep, 3 squared. So again, remember these two will always add to what your expansion is too. So this exponent up here. So next one would be 4 times. Leah, can you tell us what exponent on the x will be?
For x?
Mm-hmm.
Oh, it's 1.
Yes, good. And what about the 3?
Oh, 3.
Good. And again, 1 plus 3 gives you the 4. And last one, 1 times x to the 0 times 3 to the 4th. And so now we're simplifying. 3 to the 0 is
1.
1. 1 times 1 is 1, x to the 4th. What's 4 times 3? 12, x to the 3rd. 3 squared is
9.
9. 6 times 9.
54.
54 x squared. What's 3 to the 3rd? 27. And then 4 times 27.
Wait, you said what?
108.
Oh, shit.
Calculator's good. 108x. Let me write that 8 again. And then what's 3 to the 4th?
Wait, bet your life.
81. So again, make sure you know how to use your calculator there. So this is what our answer would simplify to. Okay, can I get somebody to pass out the homework? And meanwhile, anybody have any questions on any of this?
Come on, David. Who's David got?
I'm not.
What was that, bro?